What if we could actually turn back time?
Oh, wow.
What if we had the tools to not just understand this huge threat, but actually fight it?
I mean, it's amazing to think that we do have those tools. Some of the most powerful ones are actually scientific
Right.
formulas. Yeah.
I wouldn't have thought of that.
I know, they might seem kind of abstract at first,
Yeah.
but they give us these crucial insights into how deserts even form,
Okay.
and more importantly, how we can prevent it or even reverse it.
So we're talking about turning like complicated science into actual solutions,
Exactly.
like giving us a chance to get back those landscapes that we've lost.
Yeah.
And today, we're doing a deep dive into the top 10 scientific formulas that are changing how we approach desertification.
Yeah, we've got everything from simple ratios that help us measure how dry an area is to complex models that can simulate the entire Earth system.
That's like a whole arsenal.
Yeah.
We're going to be able to understand, predict, and even combat desertification.
Absolutely.
So get ready for a countdown of these amazing formulas. We're going to start with number 10,
Okay.
the aridity index, which basically tells us how dry a region is. But hold on tight, because at number 1, we're going to reveal a formula that is so powerful that it can actually simulate the whole Earth system.
It's incredible.
So we can test solutions before we even try them out in the real world.
Yeah, it's like having a virtual Earth right at our fingertips.
Oh, wow.
So we can experiment and predict outcomes and make smarter decisions about how to manage our planet's resources.
I mean, that's mind-blowing.
Yeah.
Okay, but let's start our countdown.
Okay.
Number 10, we have the aridity index, or AI for short.
Right. It's a pretty simple ratio that compares the amount of rainfall a region gets to the amount of water that could evaporate from that region.
Yeah, it's like a measure of how thirsty the atmosphere is.
Oh, interesting.
Yeah, so a high AI means there's lots of moisture around.
Okay.
But a low AI, that's a warning sign. It means the atmosphere is sucking up water faster than the rain can replenish it.
So it's like really thirsty.
Right.
And if the atmosphere is that thirsty, then the plants are really feeling it too.
Absolutely.
They're struggling to get water,
Mm-hmm.
which can stunt their growth,
Right.
reduce crop yields,
Yeah.
and eventually you get desertification.
Yeah, and the really important thing here is that scientists use AI not just for the current conditions, but to actually predict future trends.
Oh, okay.
So they look at long-term climate data.
Uh,
They can pinpoint regions that are getting drier and drier.
oh, so it's like giving us a heads up.
Yeah, it's an early warning system for the areas that are most vulnerable.
So we can like focus on those. Exactly.
Okay, so AI, it's like our early warning system. It helps us focus those conservation efforts in the areas that are most at risk.
Mm-hmm.
But dryness is just the beginning.
Right.
We have to understand how we're losing that precious soil.
Right.
And that's where our number 9 formula comes in,
Okay.
the revised universal soil loss equation,
Right.
or ROSLE.
Soil erosion is like a silent thief, robbing us of what we need to live. Westley takes into account all kinds of factors.
Like what?
Rainfall intensity, the steepness of slopes, soil type, even what's growing on the land.
To predict how much soil we lose over time.
Exactly.
It's fascinating how this equation takes something as complicated as erosion and breaks it down into these factors we can actually manage.
Right.
So we can see which areas are going to lose the most soil
Uh-huh.
and what we can do to prevent it.
Yeah, and it's not just about keeping the soil. It's about all the life that depends on it.
Yeah.
Healthy soil, it's full of microorganisms, insects, and all these creatures that are important for nutrient cycling and decomposition.
So when the soil erodes, we lose way more than just dirt.
We lose a whole ecosystem.
Yeah, so it's not just about dirt. It's about preserving, like, the fabric of life.
That's right.
Which is pretty profound when you think about it.
Yeah.
But let's move on to number 8.
Okay.
We're diving into water infiltration with the green-amped infiltration equation.
Okay, so picture a raindrop hitting the ground.
Okay.
What happens next? Does it soak in nourishing plants,
Uh-huh.
refilling those groundwater reserves? Or does it just run off, taking the topsoil with it and causing more erosion?
That's what the green-amped equation helps us understand.
It does. It shows us how water moves through the soil and all the different things that affect infiltration.
Like soil texture and pore space.
Exactly.
So like looking into that underground world.
Yes, and this is where it gets really cool. The equation can predict how different things we do on the land, like tilling or planting cover crops, or even how we graze animals, can affect those infiltration rates.
So we can use this knowledge to manage water better,
Absolutely.
making sure more rain soaks into the soil, recharges the groundwater, and helps the plants grow.
It's all about understanding that balance in the water cycle and using science to make smarter choices about how we manage this precious resource.
Okay, so we've got dryness, soil loss, and now water infiltration. We're starting to build a pretty good picture of what causes desertification. But before we move on to number 7, any guesses on what's next? We've covered water in, but what about water going back out?
That's a great question, and it leads us right to our next formula, the Penman-Monteith equation, which measures evapotranspiration, the process of water moving from the land back into the atmosphere.
Ah, so it's like the earth breathing out.
You could say that.
It's amazing to think about all that water vapor coming from plants and the soil going back into the atmosphere, keeping that whole water cycle going.
That's a constant process.
But how do you even measure something that big?
That's where the Penman-Monteith equation comes in. It looks at temperature, humidity, wind speed, solar radiation.
All of that.
Yeah, to figure out the rate of evapotranspiration.
So it's like a super weather station.
Right, but instead of just measuring the air, it's figuring out how much water is flowing between the land and the atmosphere.
Wow.
And this equation is really useful for all sorts of things, from figuring out when to water crops to building climate models. Farmers can use it to see how much water their crops are losing so they can water them just the right amount.
It's like giving each plant its own little hydration plan.
Exactly. And on a larger scale, scientists use Penman-Monteith to model those global water cycles.
Oh, wow.
It helps us understand how climate change is affecting rainfall, droughts, and the overall balance of water on the planet.
I mean, it's amazing that one equation can connect something as small as a plant to something as big as the global climate.
It really shows the power of science to connect things that seem totally different and help us see how the world works.
Okay, so we've got infiltration with water in, evapotranspiration with water out. We've seen how soil is super important in all of this. Now let's go deeper, literally, and explore groundwater with Darcy's Law. Number 6 on our countdown.
All right, imagine you're in the desert, sun beating down, not a drop of water anywhere.
Okay.
But right under your feet, there's this massive reservoir of water.
Really?
Yeah, it's hidden, but it's essential for life in these dry places. That's groundwater.
It's like a secret water source.
Exactly. And Darcy's Law is our guide to this hidden world. It explains how water moves through things like soil and rock.
So it tells us where the water is.
It does. It tells us where it's likely to collect, how fast it's moving, and how we can get to it without using it all up.
That's so important.
It is. We need to manage groundwater sustainably, make sure there's enough for everyone now and in the future.
It's a delicate balance.
Absolutely. And Darcy's Law helps us figure out how to keep that balance so we can use this hidden resource responsibly.
So it's like a guide to this underground treasure.
I like that.
We've journeyed through parched landscapes and plunged into the hidden depths of groundwater. It's incredible how these formulas are leading us.
Yeah, and as we go further down our countdown, the formulas actually get more complex.
Oh, really?
It reflects how much we're learning about desertification.
It shows how much effort we're putting into understanding it.
It really does. And it's not just about the numbers, it's about using what we learn to create a better future for everyone.
That's right. Okay, so we still have some amazing formulas to go. Coming in at number 5, we have the salt mass balance, which tackles a problem that might surprise you. Too much salt in the soil.
We usually think about salt on our food, right? But when it comes to desertification, it's a huge threat. When salt builds up in the soil, plants can't survive.
It's like choking them out.
Exactly. It turns good land into a salt flat.
I've seen pictures. It's crazy.
It's a growing problem, especially where irrigation is used a lot.
Makes sense?
The salt mass balance formula helps us understand this balance. It looks at how much salt comes in from irrigation water and other sources, and how much goes out through drainage.
It's like a salt budget.
Right. We need to make sure there's not too much salt coming in, or it'll mess up the whole ecosystem.
We monitor the salt balance, and we can come up with ways to stop it from getting too salty.
Exactly. Like better irrigation, salt-tolerant crops.
Oh, interesting.
In really bad cases, we can even flush the soil with fresh water.
Another example of how science helps us keep things balanced in nature.
That's right. Using our resources carefully and protecting our ecosystems.
Okay, but get ready, because number 4 is going to blow you away. It's the threshold friction velocity.
All right, picture a gentle breeze blowing across a field. Seems harmless, right?
Yeah, actually kind of nice.
But under the right conditions, that breeze can become a major force.
Really?
Yeah, it can strip away all the good topsoil and turn the land into a dust bowl.
Wow, I never thought about wind being that powerful.
It's a good reminder that even the little things in nature can have a huge impact.
But so the threshold friction velocity formula tells us when that happens?
Exactly. It calculates how fast the wind needs to be to pick up and carry away soil, taking things like moisture, particle size, and vegetation into account.
So it's like a speedometer for erosion.
You got it. We use it to predict when the wind is about to cause problems so we can do something before it's too late.
Like what?
Plant windbreaks to protect the fields, use no-till farming to leave crop residues on the surface.
To block the wind.
Exactly. It's about being proactive, not just reacting to problems.
I like that. Okay, so before we move on, let's take a minute to think about what we've learned. We've talked about the atmosphere's thirst, losing topsoil, how water gets into the ground, how it goes back up into the atmosphere, the hidden world of groundwater, and the threat of too much salt.
Each formula adds to our understanding, showing us how all these things are connected when it comes to desertification.
It's like we're putting together a puzzle, piece by piece.
And with every piece, we see the challenges more clearly, and we get closer to finding solutions.
But remember, we're counting down to that super formula, the one that can simulate the whole Earth,
Yes,
so we can test solutions on a global scale.
it's an amazing tool, and we're getting closer to revealing what it is.
I'm excited to see what it is. But for now, let's keep going with number 3. Richard's equation. Get ready to dive into soil moisture.
All right, imagine you're a plant, roots digging deep for water.
Okay.
How does that water move through the soil? What affects whether plants can even get to it? Richard's equation helps us answer those questions.
So it's like we can see inside the soil.
It is. We can see how the water is spread out, how plants absorb it, and how that affects the health of the whole ecosystem.
That's incredible.
What's really cool is that it takes all those complicated interactions between the water, the soil, and the plants into account.
It's a lot to think about.
It is. It considers things like the texture of the soil, the size of the spaces between soil particles, even the forces that hold water to those particles. It's a really dynamic model.
So it's not just about how much water is there, it's about how it's arranged in the soil.
Exactly. How accessible it is to the plants and how it reacts to changes in the environment.
This is useful for so many things.
It is. We use it to improve irrigation, predict how droughts will affect plants.
It's like a roadmap for managing water.
Absolutely. And with climate change making rainfall unpredictable and droughts more common, understanding soil moisture is crucial.
So Richard's equation is helping us face those challenges.
Absolutely. It's a powerful tool for making sure our ecosystems can adapt.
And it was developed a while ago, right?
Decades ago.
But it's still relevant today.
More than ever.
That's amazing. Okay, hold on, because we're about to go high-tech with number 2. The Normalized Difference Vegetation Index, or NDVI.
All right, imagine looking down at Earth from space.
Okay.
You see forests, grasslands, deserts. How do you tell if those huge landscapes are healthy? That's where NDVI comes in.
It's like we can see how healthy the plants are from space.
Exactly. NDVI uses satellite images to measure how green the plants are, which tells us how well they're photosynthesizing.
Okay.
Healthy plants absorb more red light and reflect more near-infrared light.
Interesting.
NDVI calculates the difference between these, and we can see how much light they're using for photosynthesis.
So it's like a giant health checkup for plants from space.
Exactly. We can see which areas are thriving, which are stressed, and even spot early signs of drought or disease before we can see them with our eyes.
That's incredible.
It's super valuable for tracking changes in ecosystems over time, seeing how climate change is affecting them, even predicting how much food crops will produce.
It's like having a dashboard for all the plants on Earth.
Yeah.
We can see how they're doing in real time.
That's a great way to put it. And when we're fighting desertification, NDVI is really important for monitoring those drylands, seeing how deserts are spreading, and whether our efforts to restore those lands are working.
This is an awesome example of how technology is changing how we understand and manage our planet.
It really is.
It's mind-blowing to think about how much data we have and what we can learn from it. We've come a long way from just measuring dryness to having these incredible satellite images.
I have.
But our journey isn't over yet.
No, it's not.
Get ready for the grand finale, the #1 formula on our countdown. Coupled land-atmosphere models, or CLAMs.
We've looked at all the pieces of desertification. Dryness, soil erosion, how water moves in and out, groundwater, too much salt, wind erosion, soil moisture, and the health of the plants. Clams bring all that together. It's like creating a virtual Earth.
So we can see how all these things affect each other.
That's right. It's more than just putting a bunch of formulas together.
It's a whole new way of looking at it.
It is. It shows us that desertification isn't just one problem. It's a whole web of factors that are all connected.
Okay, so we're talking about a model that includes everything.
We are. Weather, ocean currents, plants, how humans use the land.
Wow, that's a lot to include.
It is, but that's what makes it so powerful. We can use clams to try out different scenarios, like
Right.
what if we plant a huge forest in a desert?
Oh, wow.
Or what happens to rainfall if we reduce greenhouse gases? We run these simulations and see what happens so we can understand what our actions might lead to.
That's amazing.
It's like looking into the future of the Earth and making choices that lead to a better world.
It's giving me chills.
And clams aren't just for scientists anymore. More and more people are able to use them. Policymakers, people who manage the land, communities around the world.
Oh, it's great.
It means we can all work together to combat desertification.
It's not just about scientists. It's about giving everyone the tools they need to take care of their own land.
Exactly. And that brings us to the real heart of this last formula. It's
Yeah.
not just about the math. It's about understanding that to really solve desertification, we need to understand the local ecosystems.
We need the local knowledge.
Right. And
Yeah.
we need to listen to the people who live in those areas.
Because they're the ones who know it best.
Exactly. So clams give us the big picture.
Okay,
But the real action happens on the ground with communities working together.
I like that. Combining the power of science with the knowledge of the people who have lived on the land for generations.
That's the key.
We're all in this together, no matter where we live.
Right.
Our choices affect the balance of the whole planet.
And it's important to remember that we can make a difference. We can fight desertification. We have the knowledge, the tools, and the ability to make a more sustainable future.
That's a good point. It's not a hopeless situation.
It's not.
Well said. We've come a long way in this episode, from those dry landscapes to seeing how we can restore ecosystems.
It's been a journey.
And we've looked at so many formulas, from the basics of measuring dryness to the mind-blowing complexity of simulating the whole Earth.
A lot to take in.
But the most important thing is remembering that everything is connected. And if we work together, we can make a positive change.
Absolutely.
So as we wrap up this episode, we want you to think about what you've learned.
Yes.
Look into the resources that are out there and consider how you can be a part of fighting desertification and building a sustainable future for everyone.
Because even small actions can add up.
They really can.
Whether it's supporting businesses that care about the environment, being mindful of how much you use, or just talking about this issue with others.
It all matters.
It does.
Thanks for joining us on this deep dive into desertification. We hope you found it informative, inspiring, and empowering.
Thanks for listening.
Until next time, keep exploring, keep learning, and keep believing that together we can make a difference.
Until next time.
We've come a long way from those dry landscapes to seeing how we can restore ecosystems.
It's been a journey.
And we've looked at so many formulas, from the basics of measuring dryness to the mind-blowing complexity of simulating the whole Earth.
A lot to take in.
But the most important thing is remembering that everything is connected. And if we work together, we can make a positive change.
Absolutely.
So as we wrap up this episode, we want you to think about what you've learned.
Yes.
Look into the resources that are out there
Mm-hmm.
and consider how you can be a part of fighting desertification and building a sustainable future for everyone.
Because even small actions can add up.
They really can.
Whether it's supporting businesses that care about the environment, being mindful of how much you use, or just talking about this issue with others.
It all matters.
It does.
Thanks for joining us on this deep dive into desertification. We hope you found it informative, inspiring, and empowering.
Thanks for listening.
Until next time, keep exploring, keep learning, and keep believing that together we can make a difference.
Until next time.
So we've reached the top of our countdown, the #1 formula. This one really shows how amazing human ingenuity can be, how we can tackle these big global challenges. Coupled land-atmosphere models. Clams, as we've been calling them.
Right.
It's like all the scientific knowledge we've talked about all rolled into one.
It's more than just a bunch of formulas, though. It's
Yeah.
a way to understand desertification as a whole.
Okay.
It's not just about dryness or erosion, it's about how all these things work together.
Both natural things and stuff that humans do.
Exactly.
So this model can simulate the whole planet.
It can. It looks at everything, from the weather to the oceans, how plants grow, how we use the land.
I mean, that's incredible.
It is complex,
Yeah.
but that complexity is what makes it so powerful.
Okay, how so?
Well, we can use clams to see what would happen if we did certain things.
Like what?
What if we planted a huge forest in the desert?
Interesting.
Would that help?
Ah,
How would reducing greenhouse gases change rainfall?
I see. So you can test things out.
Exactly. We can run these simulations and see how the Earth responds.
It's like we're looking into the future.
In a way, we are.
And then we can make decisions based on what we see.
Exactly. And the really amazing thing is that clams aren't just for scientists anymore.
That's good.
More and more people can use them. Policymakers, people who manage land, communities all over the world.
That's fantastic.
It makes fighting desertification a global effort.
Everyone can contribute.
Exactly. And that's what this formula is really all about. It's not just about the technology. It's about understanding that local knowledge is key.
The people who live in those areas, they know their land best.
Right. So clams give us the big picture, the global view.
Yeah.
But the real work happens on the ground with the communities.
It's about combining science with what people have learned over generations.
Exactly.
We're all connected, and the choices we make affect the whole planet.
It's important to remember that there's hope. The desertification is a big challenge, but we can overcome it. We have the knowledge, the tools, and the ability to create a better future.
That's a really important point.
It is.
Well, we've come a long way from those parched landscapes to talking about how we can restore those ecosystems.
We have.
We've explored all these formulas, from simple ones to incredibly complex ones.
It's been quite a journey.
But the key takeaway is that we're all connected. And if we work together, we can make things better.
I agree.
So to wrap up this episode, think about what you've learned. Check out the resources that are out there. And think about how you can be a part of fighting desertification and creating a sustainable future.
Even small actions matter.
They really do.
Supporting eco-friendly businesses, being mindful of what you use, talking about this with others.
Every little bit helps.
It does.
Thank you for joining us on this deep dive into desertification.
It's been a pleasure.
We hope you learned something new, felt inspired, and feel like you can be a part of the solution. Keep exploring, keep learning, and keep believing in the power of working together to make a difference. Until next time.
See you then.